All right, good morning, everyone. Good evening, wherever you are. Welcome to the May virtual meetup for the IBM Data Science community. We had to postpone last month's event to today, so very glad you can join us. We have a cool program for you today. We're going to learn about the Elyra Visual NLP Editor, very exciting stuff. And as I understand, it's IBM's latest contribution to the open source ecosystem. We'll learn about that. Today, we're going to give it a couple minutes. We have a slightly different registration process than usual. And for the folks joining at the last minute, it may take a couple of minutes to get the join link from WebEx. So we're going to give them a couple of minutes. We have a few announcements, and then we're going to dive right into our main talk with Laura Kitikariu and Jesus Rocha Guerrero, both IBMers, and it should be fun. If you have any questions, how do you guys want to handle questions? Should folks ask questions during, or you want to keep until the end?
I think during is okay, and if we see that there are many questions and we won't be able to get through all the material, maybe we can just say at some point that let's keep questions to the end.
Awesome. All right. So guys, you know what to do. If you have questions, just use the chat or the Q&A, however you prefer. Also, if you want to introduce yourself, feel free. Tell us where you're from and what brings you here today. This is usually a very global audience, and we love to see what countries or cities you're from. Awesome. There you go. Great. Welcome, Hemant from Bangalore. Berlin, nice. Spain, awesome. Madrid, we have a meetup in Madrid. Thomas, they just started to go back to in-person, doing in-person or hybrid events, so you should check it out. I'll post the link later. Great. Turkey, merhaba. Awesome. All right, cool. So the way this works, these are monthly virtual meetups of the IBM Data Science community. The way they work, they're intended to be, fairly informal. So we're hoping to get lots of questions from you and comments. So these speakers are there to answer your questions, among other things. So don't be shy. Feel free to ask away. I'm going to start with a few announcements, and then we're going to dive right in. All right. So first of all, if you haven't done so already, please consider joining the IBM Data Science community. If you come here via Meetup or via our partner today, it's a great place to explore, share, learn, build together with other data scientists and folks in related fields. So give it a look. And if you join, there's a complimentary 1-month free access to select IBM courses on Coursera. I'll post all these links into the chat in a little bit, so no worries. These courses are great, so don't miss out. In addition, we just launched a new Manning Live project, which is super cool. Definitely give that a look. It is free. It's normally about $30, but courtesy of IBM, it's free access and super fun. So basically, you're a data scientist looking through large volumes of text and trying to make sense of that using a bunch of cool technology. So very fun. Shout out to an event that's coming up in a little over a week, June 14th. IBM Developer. It's a half-day conference. They say it's going to be super accessible and fun with some hands-on elements, so give it a look. Free as well. Yes, Zahid, the manning is suitable for beginners as well. And then last but not least, if you are interested in getting involved in your local area, we have a network of over 100 local meetups around the world. So check out the map. I'll post the link into the chat. And if there's something near you, or if you want to start something near you, there's a Slack where we are kind of grouping the organizers together and trying to get everyone involved again after the pandemic or at the tail end of the pandemic. Cool. Yes, I will post all the links into the chat in a little bit. And with that, I'm going to hand it over to Laura and Jesus.
All right, thank you very much, Tim.
Thank you, Tim. Hi, everyone. Let me go ahead and start sharing.
Oh, you're sharing, Jesus. Yeah, go ahead.
Screen 2. Okay. Okay.
Hello, everyone. Thank you very much for coming, and thank you for your interest in visual NLP. And let's go to the next slide so that we introduce ourselves. So my name is Laura Chiticariu. I'm a long-time IBMer. I've been here for 14 years, and I've been working on NLP pretty much since I joined in 2008. And my area of specialty is natural language processing, and I'm currently leading the IBM language development across the entire IBM. Jesus?
Yeah. Hi, everyone. My name is Jesus Rocha Guerrero, and I am a full stack developer. Been doing so for 15 years now. And as of the last 3 years, I've also been engineering manager. I joined IBM less than a year, and I come from background working in financial institutions in the U.S. And now I'm proud to be an IBMer.
Awesome. All right, so today we have a very packed agenda. So we are talking about the visual NLP editor. And the first thing that we will do is introduce the open source technology that we use to build the editor. This is the Elyra technology that IBM has developed in the open source. And that's a very cool technology for building pipeline-like user interfaces. Then we will talk about the visual NLP editor itself. The editor today has a backend to IBM SystemT. This is a IBM internal NLP engine that powers NLP across a variety of IBM products. Then we will show you how you can export a model built in the editor and deploy it to one of our language offerings in IBM called IBM Watson Discovery. And we'll talk a little bit about what Watson Discovery is. And finally, we will conclude with our future plans for further developing the visual NLP editor.
Okay, so I will start talking about the Elyra Common Canvas. So as an engineering manager here at IBM, I am now leading the team that is contributing to the open source Elyra Canvas. And this is a product agnostic, white label, solution that enables any host application to build on top of and have different pipelines that will contribute to different, solutioning. So what are the characteristics of Elyra Canvas, you may ask? So here I have a couple of out-of-the-box capabilities that come with Elyra Canvas. We have, first of all, the common canvas, which you can see the first picture here is your view into your collection of what would be nodes, links, supernodes, comments. It would give you a full picture of all of your connected graphs or pipelines or different ways to construct. So we have then in the next picture different nodes that you can customize. So the Elyra Canvas does not come with any prescribed, well, it does come with some default nodes out of the box, but any host application can override these nodes and make them specific to their applications. And then the next thing that comes out of the box is the ability to connect nodes together via inputs and outputs that are specified by the host application. And then as your flows get more complicated, you have the ability to abstract, make them into a super node so that you put those aside and you know that's what the super node is doing, so then you can connect to other systems. And it just enables you to have a more organized, canvas. And then we also have comments, which will enable you to annotate and give information for others that may come to the canvas, and be able to have a much easier time understanding what exactly is happening. So after the common canvas, we have what are called panels. And so we have different panels. We have a panel on top, which is where our toolbar goes. We have a panel on the right, which is where our common properties, and I'll talk more about that. And then on the left, we have palettes that are prescribed by the host application to different types of nodes that want to have different labels, different characteristics, different icons. There's a lot of different configuration that goes into Elyra Canvas. None of it is prescribed. The host application gets to drive a lot of it. And in the terms of palettes, we offer capabilities out of the box, such as categorization of different nodes to different categories that have accordion that you can open and close. We also have a search capability, so in case you have too many nodes, the user can quickly do a search and find the node that they're looking for. Up at the top, we have the toolbar, which comes with some out-of-the-box capabilities, such as navigation. So for example, you would have icons that would enable you to press in order to zoom in, to zoom out, to be able to zoom to a perfect fit. And then in addition, we also have, the mouse gestures that work just as well with the scrolling in and out to zoom in and out, click, hold, and drag to move your canvas around, like panning. And then in the toolbar, we also have the capability to enable undo and redo capabilities. So as you're working through the canvas, if there's anything you need to undo, you can always go back and do so easily. And then the toolbar also enables the host application to prescribe different capabilities that the Canvas application, Elyra Canvas, will just emit events upward for the host application to then handle and do what is needed. And then our primary, function for a canvas is to be able to execute and run a pipeline. So once things are set up in place, then, when you are ready to execute, we have, a highlighting of a toolbar button you can see on the lower right, which is blue, and enables you to see where your action buttons are. So these are all the capabilities that come with the Elyra Canvas out of the box. And next, I will walk you through a couple of examples where this is used. So as being the engineering manager for the open source product, I am also the engineering manager for the SPSS modeler that IBM provides as part of the Cloud Pak for Data on-prem and also our on-cloud solution. And this is the central diagram that you see here. We have the palette laid out on the left with all of the different options that you can open up categories, select different types of nodes for import, different operations. And then over on the right side, we have common properties. So common properties is just declarative forms that you get to specify. I need this input, I need this text field, I need this checkbox, without really having to write HTML. You just tell it what to do, and you don't really care how it does it. So it gives you all of the results back. You can pass in any error handling, so you can provide notification if there's any input field that needs to be filled in. You can provide all of that declaratively. And then you can now see here the bottom panel, we also have a table where we can output more information, and we have the toolbar at the top with our out-of-the-box capabilities for moving the canvas, and then our run selection. So that's just one major example. And then over here in the background, we also have data stage, auto AI, other canvas-based solutions. And then when we think about pipelines, we think about two different kinds. We have a generic, which is just stepping through a different flow, executing, different parts of each node independently. And then we also have the runtime base, which takes the entire pipeline identifier with all the nodes to it, and then it sends that to a runtime engine to execute it. So there's lots of different, capabilities that the host application can be configured to do. But Elyra Canvas doesn't prescribe anything. We delegate that to the host application. So that's it for this part. Now I will hand it over to Laura to continue presenting the next slides.
All right, so now let's talk about the visual NLP editor. So before we talk about that, we have to be very clear about what kind of focus we have with the visual NLP editor, right? Because there are many things that you can do visually, like for example, you can build a neural network using, putting building blocks together, all the layers together. That's not our focus here. Our focus here is to define NLP business logic, which is also known as NLP rules, by combining different kinds of things that are useful in building NLP applications. Those things include pre-built concepts and models, for example, a transformer-based entity extraction model, or a part-of-speech tagger, or a semantic role label model, or a sentiment model, and so on. Atomic simple extraction primitives, such as regular expressions, gazetteers. Text span-based operators that allow you to combine the results from multiple models in interesting ways. For example, doing things like joins based on span. Does this span contain this other span? Is this span followed by another span, and so on? And other kinds of operators that are useful in general, like for example, merging results from two models, or computing a set difference between two results, sorting, grouping, and so on. So that's going to be our focus for today. And, some of you may actually wonder, but wait a minute, today in the modern era of AI, we have all of these transformers, and they can do all these wonderful things. They are very multilingual, and they can handle many tasks, and, you maybe don't need that much label data to train them, and so on. So you may wonder, well, why are we talking about NLP rules? Aren't NLP rules a thing of the past? But it turns out NLP rules are not quite a thing of the past, because they have quite a number of applications in practical real-world use cases. And I'm going to talk about 3 different kinds of applications. 1 is to accelerate data labeling. 2 is to find simple concepts. And 3 is to express NLP business logic across more complex models. So let's talk a little bit about accelerating data labeling. So there are a number of companies today that use rules for essentially running them over a large amount of data and creating weak label data that can then be used to train machine learning models. And here we have a quintessential example in snorkel.ai, which does exactly this thing. A second application is to find simple concepts. For example, maybe I look for things like percentages, or maybe I look for simple phrases like, revenue of 5 billion or income of 3 billion and so on. So for simple things like this, right, sometimes maybe you don't want to label a bunch of data so that you train a machine learning model, and some very few number of patterns may be good enough. And if those patterns are not good enough for the application, it turns out that, well, you can go back to number 1, where you can use those patterns to do some weak labeling of data and then train a machine learning model. So it turns out that there are a number of use cases like this, and the systems that handle this use case, both in open source and in commercial products. So here we have an example from Spacey, right? Spacey has a rule matcher, and they have a very nice UI for putting together simple patterns for matching in the text. And at the bottom, we have an example from one IBM product called IBM Watson Knowledge Studio that allows users not only to train machine learning models, but also to build simple rule-based models and then use those rule-based models to do pre-annotation of data that then is used to train machine learning models. And then finally, the third use case is expressing NLP business logic, right? So let me give you an example. And this example is from Fred Rice. He gave a talk actually in the last meetup in April, a talk on introduction to text extensions for pandas for NLP use cases and Ray to scale compute intensive Python workloads. So this is an example from Fred's talk. And he gave an example on, you want to solve a relatively simple task, right? So you have a bunch of press releases and you want to find executive names from press releases, right? So of course, we don't have a list of executive names, so we want to discover them and how you might be able to do that. Well, you might want to look for people names in these releases. And then you might find facts that indicate there is a quote, right? Somebody said something. And then basically you want to just get all those people names that are contained within one of those quotes. Well, I think we all know that, finding people, finding facts are actually hard NLP problems, right? Named entity recognition, coreference resolution, semantic role labeling, sentiment analysis, and so on. These are tasks that have been studied for decades, right? So we would expect to spend a lot of time there, and then we would expect to, matching facts with people would be very, very easy. Well, it turns out that that's not quite so, right? First of all, the hard tasks are, available as off-the-shelf models. I could take an off-the-shelf NER model for finding peoples and organizations. I could take an off-the-shelf model for semantic role models, run it on the text, and I get my people and I get my facts. But surprisingly, then writing the code that matches these facts with the people is actually quite hard. And I really love Fred's quote from his talk last month, in which he's saying that in NLP, the easy things are hard, right? And why is it hard, right? Well, you have to write a bunch of code for the simple task of matching people with facts. So, suppose you have your people and you have your codes and, there's a bunch of code here, and I will spare you the details, but essentially, naively, what you would do is join all your facts with all your people, but that would be kind of bad because, well, the complexity of that would be quadruple in the size of the document. So maybe you want to do something smarter, like maybe you want to split your document into chunks and then basically match people with the facts across the chunks, which means that you have to build some lookup tables and then you may get some duplicates, then you want to remove those duplicates and so on and so forth. So it's quite a lot of code that you have to write, and then you have a slightly different task. You start writing more of this code over and over again. So in turn, what Fred has presented last time was a language called text extensions for pandas, which essentially extends the panda data frame paradigm with text-specific and span-specific operations, like text-specific joins, finding matches for gazetteers, and so on. Right? So for example, this is how you would go from those 40 lines of code to a single line of code using these text extensions for pandas, where notice over here that there is an explicit contain join that checks whether a span having a subject of a quote contains a span matching a person. So I fully recommend and thoroughly recommend watching Fred's talk if you haven't already. Because he's talking about how easy it is to do this NLP business logic using Panda data frames with the text extensions. You may also go to this link over here to check out the text extensions for pandas in more detail. So with that, now let us talk about our NLP visual editor. So the paradigm for the editor is as you would expect, right? So we have a low code or no code interface that puts together NLP business logic flow at the top. Then internally that flow compiles to different NLP runtimes. In today's talk, we will talk about the IBM SystemT NLP runtime engine. But our plans are to extend to text extensions for pandas. And, of course, the community, all of this is in open source, so the community may extend to other runtime engines, for example, Spacey or other engines. And then, once you have those models compiled, the UI displays the results on input documents, right, for the developer to test their business logic. Results will show up in a table and also highlighted in text, so you can see where your model matches in the text. And then finally, you will export and deploy the model in your application. And today we will see how to do that with IBM Watson Discovery. So now let me hand it back to Jesus, who will give a demo of the NLP editor.
Okay, so today we'll continue with the NLP Editor demo, and the use cases here is we're going to talk about having an input document using different extractors like regex, literal, dictionary, do some generation of sequences and unions, do some refinement, and then save, load, and then export. So here we have our text editor. First thing we do is grab a document as an input item. We're going to go ahead and select a file. So we're going to use financial statement from the fourth quarter, 2006. And then the first thing we're going to do is look for a metric. We'll call this metric, and the value that we're looking for, revenues. Then we save. We go ahead and connect our literal from our input node. Then we go ahead and run and see the first set of results. One of the things I'll make everyone aware is our highlighting feature on the right side is currently broken. But in the ideal scenario, you would have the ability to select and find where there are a lot of different items highlighted on the right. So right now you can see that it highlights everything, but as you were to click one of these revenues, it would show you directly on the right side where it would be located. So now let's go ahead and build, after revenue, let's go ahead and search for different divisions. And what we're doing here is we're trying to extract a lot of knowledge from these financial statements. Okay, so we go ahead and we've defined a dictionary, which gives us a number of terms. And then that will give us the same results that we would see with the literal. So now taking two of these extractors, we can generate a sequence from them. So we're going to have two different sequences. The first one is going to be metric comes before the division, and the other is the division comes before the metric. So we'll join those here. So then we open up our sequence configuration. We'll call this revenue by division 1. And then this one will be our revenue by division 2. You can see here that the sequence pattern is inverted. So the first one has metric before sequence, and then this one has division before metric. So let's change our token, and then let's go ahead and run one of these sequences. Also, as of the latest build that I got on the runtime last night, sometimes there is some caching that sends me the results from the previous. So if I encounter any of these errors, I'll just go ahead and do a quick reload to see if it goes through. But in the beginning, it tends to be pretty good. So here we have revenue by division, where we have the division first, followed by the metric. And then the other one would yield us the inverse. It would say revenue from software or revenue from global technologies. So that's what we've constructed here. Next, we're going to take both of these different sequences and we're going to create a union from them. In order to create a union, we're going to need to change the attribute settings. So we're going to have to align both of these to be called the same thing. So revenue by division. Okay, let's go ahead and make sure I got these both the same. Revenue of division. Revenue of division. Wait a second. New by. Okay, and next we will join these to a union. And then when we open up the union, we have to also specify the name of division. Okay. Yes, so revenue by division is the attribute output on both of these sequences. And then the union will have revenue by division. Yeah. Getting those confused. Okay, so now let's go ahead and run our union node. Okay, so in revenue by division, we have revenue from software, revenue from global technology, and then we also have software segment revenue. So this was our union here. We also have the results from all of the other items here as well. Okay, so now that we have revenue by division, let's go ahead and use a regular expression to extract the amount. So let's see, open up this. Let me get my regular expression here. Okay, and then we'll change this to be the amount. So when we run the regular expression amount on this financial statement, it'll just print out all of the different, 1.1 billion, 1.2, 2 billion, 3 billion, all of those will be found. And then let's go ahead and take our union of revenue by division and then join it with our amount, and we'll call that revenue of division. So we bring in our union. Okay, and then here we're going to look token between, I think it already has, between 1 and 30. Okay, and let's go ahead and run this. Okay, and then here we have the different revenue of division. So we have revenue from the software segments, 5.6, revenue from global technology, 8.6. And then here in this item here, we'll see that there is an issue. It has software segment revenues 18, but then there's also an overlap with another revenue from technology division, which was 32. So this is where we're going to have to do then some refinement. So if we take then a consolidate node, move that in here, and then we can then say our sequence will need to be consolidated so that it's not contained within. There's our first error. So let's go ahead and retry that.
It wouldn't be a live demo if there's no error. That's what I learned in my 14 years.
Yep, we got the latest nightly build from yesterday. So yeah, we are Definitely on the latest, but I do have some backup screens to show you how this would work. So as we have here, we're now on the consolidate. So let me go ahead and run it from this one and let's see the output. There we go. So in the consolidate, that gave us the previous cache. So let me go ahead and run it again. And it should show on the bottom table a consolidate that has the ideal results that we're looking for. Here we are. Great. So here we go. We now see that we don't have any more overlap between two metrics and the amount. So now that we are in this diagram and we've completed the rest, let me go ahead and show you another flow that is coming over here on the side. This one is a sentence boundary. So sometimes you will have selections that are captured over two sentences and we want to be able to break them apart. So here we have regular expression for identifying sentences. And then here we have a dictionary where we don't want the abbreviations to be included in the sentence boundary. So we apply a filter. This filter says exclude sentence boundaries that are overlapped by the abbreviation. So let's go ahead and then run this as an example. And then that's giving us the previous result. So let's go ahead and run it again. Okay, so here I don't have the exact numbers here, but you can trust me on this. Sentence boundaries, there's a total of 82. And then abbreviations, there are a total of 4. So then the filter would yield a total of 78. And right now, we don't want to count these. And one of our features would be to give you the exact number so you can see that your filter was applied correctly. And so now you're properly separating the sentences. And then now back to our sequence, we want to then do a filter based on, so we can filter the revenue by division to not to contain the filter that we generated from the sentence boundary. And then when we run this, it'll give us some other similar results to the consolidate. Let me run that again. Okay, so our second filter is here, and this is what captures very similar output to the consolidate. It is very simple and clean, easy to read the facts from this financial statement. And then from here, what we can do is we can save this flow, and so that'll generate us a JSON format output. I'll talk more later on what this structure looks like. And then what you want to do here then is if you want to export these results, you can then click on the export, and that'll open up a new window, which will then drop a zip file. This zip file, I'll hand it over to Lara, which will continue in the next part when it's her turn to upload that to Watson Discovery. And then say then you want to start a new flow. Right now we don't have the capability to reset it, but we would just do a simple reload. And then if you want to open up any of your existing flows, you can go ahead and look for it. And then one of the things you'll notice in this flow is that it has the labels on all of the different nodes so that it's easy to see and go through and see how things are being populated. In my previous example, I didn't have that, so this is something we are looking to fix as well. So that I think is all of the portion for the demo. So now I will move over to the next slide and have Lara speak a little bit more about, oops.
No, where did it go?
Where did it go? Here it is, from the current slide.
Awesome. Yeah, so you have seen a quick demo of a number of constructs that are available. So you have seen some of the atomic constructs that exist. We've seen dictionaries, we have seen regular expressions, we have seen proximity, right? Trying to match things across a range of tokens. We haven't seen import existing extractors and script, which allows you to escape to custom code to handle long tail use cases, which are not handled in the expressivity of the visual UI. These are things that are not available today, but we plan for the future work. Next, you have seen composition constructs, right? How to put together different atomic things into a sequence and how to union results from multiple concepts on the canvas. And then finally, you have seen some examples of refinement constructs. Next, you have seen filter and you have seen consolidation. These are standard operations on removing unwanted outputs and consolidating things that overlap and so on. Again, here we have a few different things that we plan to add, like a projection, removing certain attributes, or adding a function call on the output. For now, those are not there yet.
Okay, and then I will talk more about the NLP Editor architecture. So the way it works is we have 4 components. We have the UI, which is a React-based application. We have a server, which is a Node.js. And then we have a shared directory that is what is used to integrate between our server. And then the 4th component is our runtime. So here in the first model that you see here, step 1, in order to get our pipeline out to our runtime, we first have to have the UI export all of the nodes from Elyra Canvas, and then it does the construction of a XML, and then that XML is then sent over to the server. The server will then take those XMLs and then zip them up into a file, and then it will drop them into a shared directory on the input folder. And then the Java runtime, the runtime, which is a Docker container, is continuously scanning this folder. So as soon as it puts something in, then the runtime picks it up and it starts processing it. And while the runtime is processing it in step 2, then we go to step 3. The UI right now continues to pull, ask for the server, is there anything on the output folder? And the way that we send things to the format that we use to identify is we use a unique UUID, and that's what the server or the UI is telling the server to check if there's any outputs in that folder. And then once it finally, the runtime completes in step 4, it'll put the output into that shared folder. And then the server will then, or the UI will then be able to tell the server to find it, and it'll be able to send the result back up. So that's how you do a run, where you get the, you define your pipeline, and then you get the results that you see on the table. And then the similar process happens with the export. The server notifies the runtime by dropping a file into the shared directory. Then the runtime knows that you want to export these features, and then the server or the UI is telling the server to pull and look for when the export is available, and then that's what becomes the download. Over here on the right side, now we discuss how the UI and the JSON flow schema work together. The JSON flow schema is what the Elyra Canvas uses in order to, when we do the open and save, we have to follow this schema in order for Elyra Canvas to be able to know where the placement of the nodes were, what their links were, and any data attributes that the host application requires. So this is all based on a spec that we have in our Elyra Canvas folder. And that is, how things are saved. So I will now hand it over to Laura to continue the rest.
All right. Thank you, Jesus. All right. So now let's quickly talk about the IBM SystemT NLP engine, which is what we use in the backend. Okay. So this is an engine that powers all the rule-based NLP in IBM offerings. It provides something called AQL, Annotation Query Language, which is a declarative language for expressing NLP business logic. And it's a high throughput, low memory footprint, very, very fast implementation in Java. It has an optimizer that compiles AQL code into a super fast execution plan, and that's what gets executed. Lots of optimizations went into that, and I could talk for hours on what they are, but that's subject for another talk. If you are interested in more details, links over here point to the specification of AQL and also an overview paper that we gave in NACL in 2018 in the industry track. So here's an example of how AQL is used to translate behind the scene regular expressions, right? So this is what AQL looks like, and you can kind of see the correspondence between various pieces in the AQL rule language extract regex statement and the parts of the UI that are used to generate this code. Right? So we have a mount, that's the name of the rule, and then you have a regular expression, and then you have a bunch of flags and some token specification. And then we also have some return function, which essentially returns different parts of what is being matched by the regular expression. Here we return the entire match as a mount, and we also return what's in group 1 and group 2, the capturing groups of the regular expression. Okay, so this is, should look familiar for those folks who are used to SQL, right? The query language for querying relational databases, but it is catered to text. So here we have a statement explicitly for finding matches of a regular expression spanning 1 to 4 tokens, and then return the match plus whatever comes out of the capturing groups. Everything here comes out as a span data type. The span data type contains the begin and end character offsets. That's how we are able to highlight the matches in the text. That's something that Jesus showed. And the output here is organized in tuples with 1 or more attributes. Okay, very similar to the relational data model and the Panda data frame model. Here's another example of what a filter looks like in AQL. Right, again, the correspondence between different parts of the filter. And here, essentially, we have a part of this statement which finds spans that overlap with the sentence boundary. And then notice over here, there is a text-specific span-based join predicate contains. This checks if one span contains another span. And then the second step is to subtract these overlapping spans from the result. So AQL, again, full specification available in the previous slide. And it actually has a lot of primitives that allow you to do and build complex NLP logic. Right? It has NLP primitives, including tokenization, lemma, parts of speech, and shallow semantic parser, span extraction operators, regular expressions on character level or token-based level, dictionaries with different match semantics, case sensitive, insensitive, matching on lemma form, sequence patterns. You've seen examples of this, right? Regular expressions over tokens and other annotations. And then lots of relational operators, text-based joins, like contains on overlaps and follows and so on, and all kinds of operators useful for merging results, sorting, grouping, set difference, and so on. And a few others that I will skip in the interest of time. So now let's talk about how you would use this with IBM Watson Discovery. So first of all, what is Watson Discovery? So Watson Discovery is a product available as IBM Cloud SaaS offering, as well as on-prem in Cloud Path for Data. And this product allows you to analyze large collections of documents and apply NLP methods on those documents, and then analyze the results or be able to search the results to build your application. So it has a few different steps. It allows you to connect to data in different repositories, SharePoint, Box, internal web crawl, and so on. It allows to work with data in different formats, things like Word, PDF, HTML, images, and so on. It allows you to define different constructs that allow to understand the document structure, things like sections, subsections, tables better, enrich the content with natural language and document structure understanding, both out of the box and custom models built from data. And then all of this is fed into either an analysis application to find insights on the large corpus, or essentially fit the results to natural language questions. There are many enrichments that are available in Watson Discovery, models for entities, relationships, keywords, sentiment, and so on. But what I wanted to show is actually how to upload the result of the NLP model that we built in the NLP visual tool into Watson Discovery and show the results. So let us go to my instance of Watson Discovery. So I have here Watson Discovery in Cloud Pack for Data, again, available in SaaS also. And I have my collections over here. I can go and create a new collection. And over here, you can see that you can connect with many different sources of data, like SharePoint, Salesforce, web crawl, a database, and so on. For me, I may choose to upload the data for my computer, right? So I can create a collection here. And I may choose a PDF document, for example. So I have a PDF document over here, which I can choose to upload, and it will start uploading. But I have actually created a collection behind the scenes, so we can go to that collection. So over here in Improve and Customize, we actually have the opportunity to teach domain concepts. And in Discovery, you can teach different kinds of domain concepts, like just simple dictionaries, simple regular expressions. You can train your classifiers. You can use machine learning to build, entity and relation models. Then we have this thing called advanced rules models. So this is where we can upload the model that Jesus has exported, right? So here we have our model that was exported, and we can upload it. And then once we upload it, we have to specify which field it will apply to. In this case, maybe I want to apply it to my text field. And the collection will start processing, and I should be able to see the results. Well, I sort of ran this model before, and I can show you what the data looks like very quickly. So here's the document in Discovery. I have ingested the PDF, and you can already see that you get some document structure like the title and some formatting, right? Some subtitles over here. So that's really good. But the actual result of the model will show up in the output. So I have said that I am going to enrich the text field, and this is where I have my results of my Elyra model. So you have here some of the things that you have seen in the demo earlier today, right? Catching things like revenues from the software division, revenues from Tivoli, and so on. So very quick demo, and now let me jump back to the presentation and talk about our future work. So we have a few different things on our plate that we're working on. First, we want to add an additional backend to text extension for pandas. We mentioned it earlier. It's available on open source, and we want to enable this as the second backend. And of course, the community can go ahead and add other backends as they wish. We want to add a few new different kinds of nodes, including importing an existing model and a generic script that falls back to custom code whenever the expressivity of the UI is not enough to express what you want. And then we also have lots of general usability enhancements, like enable development with multiple documents and so on and so forth. So now we reach the end of the talk, and I have a call to action. Basically, try it out. We have here the resources for Elyra Canvas. This allows you to build a very wonderful visual editor for any application that you have in mind. And from our experience, it only takes a few weeks to set it up. Basically, the hardest part is to make it compile into something, because the UI part is pretty much taken care of, and all you need to do is to declare what kind of nodes you want and what icons they should have and how they should connect with each other. And then the Elyra NLP Editor, right? This is an open source NLP editor from IBM that we have seen today. It is extensible to multiple backend engines. Today we handle the IBM SystemT engine, but we're working on the text extensions for pandas. And as a community, go ahead and add one more backend engine. We will be very happy about that and very eager to learn about your progress. So here are the documentation and the source code, and feel free to try it out. And now I'm going to stop talking and see if we have any questions. We answered a number of questions from the chat earlier, but I don't know if there are more questions. Feel free to speak up if your question was not answered.
Yes, thank you both so much. There's a couple more questions, I think. Any plans to integrate with Knowledge Studio?
Yes, a very interesting question. Definitely plans.
Okay, and then also, is the NLP editor mostly focused on information extraction?
Yes, the editor is focused on information extraction. Though if you have things like a classifier, let's say a classifier for sentences, once we have a backend to text extensions for pandas, then you can combine, you know, a sentence classified with different NLP logic operators, and you can build something on top of it.
Awesome. And Sajjad Hussain asks, if I have a few pre-trained models, can they be integrated?
So there are two options there. Once we have text extensions for pandas, you can build an extension to that so that the pre-trained models can be handled through text extension for pandas. If your models are in Spacie or Hugging Face, they should be already available. But if not, then you would add, you know, your runtime to text extensions for pandas. So that's one option. The second option is, depending on what your pre-trained models are, if they are amenable to be run in a different kind of engine, like Spacie, then you would add a second or a third backend to the NLP editor.
Cool. Well, thank you both. Any other questions you have on your mind, folks, please post them into the chat right now. Otherwise, there will be a follow-up post with all the links, the slides, the recording that will be posted on the community over the next few days, and you can always engage there and ask comments there. More questions. Is there, in the annual reports, does it extract info from the tables also?
With text extensions for pandas, there is integration with IBM Watson Discovery Table Understanding, and then you can express business logic on top of results from table understanding. There's another question of, is this purely rule-based information extraction? And the answer is yes. The canvas is for expressing NLP business logic, but then the models that go into it, for example, from text extensions for pandas, are machine learning models.
Cool.
And yes, you can extract entities and you can extract relationships. Like you saw in the table that I showed, there are different attributes. That's essentially the relationship between different spans. And again, this is not machine learning. This is purely NLP business logic on top of models. Whether the model is rule-based or machine learning-based, it doesn't matter. But the NLP business logic is just that, logic, meaning rules.
All right. Well, you're right on time. Perfect timing. We got 1 minute to go.
Awesome.
Yes, thank you both so much. This is great. Just give it one more second here. Any thoughts on verbal output?
Oh, someone has to explain what that means to me because I don't understand.
Jack, you want to maybe expand on that?
Yeah, and LinkedIn connection, please hit us on LinkedIn. Yeah, verbal output, Jack, you're from IBM, so just like me.
Okay.
But if you're asking about speech to text, this is not for speech. It is for text. So if you have speech translated to text using Watson speech to text service, and then put it in this tool. No, this is not for speech.
Okay. All right. I think we're at the top of the hour. Thank you again. This was great. I will follow up with you on collecting all the things that you shared today so we can make sure to share it with the folks who are not able to join live today and they can follow along in the recording. And good luck with your next steps on this amazing tool.
Excellent. And I hope we can come back in a few months and show all the progress that we have made. Meanwhile.
Always. I'm going to stop the recording and then we can hang out for a few more minutes. Thanks, everyone. Be safe. Have a good day.
Thanks, everyone. Have a good day.